In this section we're going to cover derivatives of the inverse trig functions. So before we jump into the calculus part, let's first do some pre-calculus review here. So before we take a look at this table, let's look at this to review the basic understanding of how inverse trig functions work. Basically, what normally you would have for regular trig functions, you put an angle in and you're going to get a value. Now the value for, if you're working with sine and cosine, these values come directly from a unit circle. So if we're doing inverses, just the opposite is true. You're putting a value in there, so you're putting a value, if you have inverse sine and inverse cosine, those are coming from the unit circle, that's going to give you an angle as a result. So that idea is expressed here with domain and range. Domain would be the inputs, what you can put into for something. So because we're dealing with inverse trig functions, that's going to be a value. So for inverse sine, inverse cosine, it makes sense that the values we have should be between -1 and 1, because that's the type of values that you would get from a unit circle since it has a radius of 1. Now the value you get, the angle you get as a result here, that's going to be reflected here in the range. So you can get between negative pi over 2 and pi over 2 brackets, and we have brackets on this 0 to pi. Now where do these ranges come from? Well, this you would have to take a look at the graph of an inverse trig function to see where all these ranges and all these 6 trig functions, you'd have to look at a graph. Now we're not going to look at the graphs of the inverse trig functions in this class, but that's what you would look at in order to find out where these ranges come from. Okay, so these would be the angles that you can get as a result. Now inverse tangent, you can put anything in there, negative infinity to positive infinity, but you are still restricted with the angles you can get. Keep in mind that this one here has brackets, this one has parentheses, so we're not including the endpoints for inverse tangent. Now these down here, you may or may not have seen these depending on which class that you had for pre-calculus. Sometimes they go over these, sometimes not, but this is all the domain and ranges for those. So again, for domain and ranges for these bottom ones, again, these are going to come from a graph. So if you look at the graph of these inverse trig functions, that's where you can find out what domain and range should be by reading it off the graph. And so I have all these listed here. In the notes, I originally wrote all this in terms of inequalities, but I decided to rewrite them as intervals because it looks a little bit easier to see. So these down here, basically they're using inverse cotangent. You can use anything, but these two are restricted. You can basically use anything except for numbers between -1 and 1, so it's just the opposite of the ones that we had up here. Okay, and then this is the ranges, the type of values you can get as a result. This you can get any value between 0 and pi if you're talking about the range of inverse secant, except for pi over 2 you can't include itself because that's where we have a vertical asymptote, it's undefined. And then down here for inverse cosecant, again keep in mind that the endpoints are not included. So now we've taken a look at this table and gone over the domain and ranges. Let's now look at some examples. Okay, we just looked at the domain and ranges for the 6 inverse trig functions. So now we're going to take a look at these problems to kind of highlight some of those. Now one thing you want to keep in mind is the values that you have inside here have to match or be in the same interval as the domains that we had that chart on the board here. So all these here should fit your domain. If they don't, if this number falls outside of your domain, then it means we can't do the problem. It's going to be undefined. So that's always the first thing you want to check, is to make sure the value fits your domain there. Now to get the answer, we're going to take a look at this table. Now this is a table that should look familiar to you from pre-calculus. If it's been a while since you've seen it, I wanted to review this for you. This is your 3 trig functions, just sine, cosine, tangent, the values between 0 and pi over 2. You could get these values off the unit circle as well, but I'm choosing to give it to you in the table format. And we're going to use this table actually to answer all the problems on the board. So for part A, we have square root of 3 over 2. We want to find what angle is associated with that value of square root of 3 over 2. Normally you have sine of an angle gives you a value. Well, now with the inverse trig, we're starting with the value, you're going back to an angle. So to answer that, we look at the sine column, we go down until we see our value inside, square root of 3 over 2, and you're going to go across and indicate what angle goes with that. In this case, the angle is going to be pi over 3. Normally you would have sine of pi over 3 gives you root 3 over 2, but we're starting with the value, so inverse sine of root 3 over 2 will give you pi over 3 as the angle. Next, we have inverse cosine 1 over square root of 2. 1 over root 2, remember that you can rationalize this, and you want to rationalize this one first because we don't have 1 over root 2 on our table here. So square root of 2 over 2 is the value we want to look at. Inverse cosine means we're going to look at the cosine column until we reach root 2 over 2. The angle with that is pi over 4. Okay, so that's the answer for B. For C, we have inverse tangent, root 3 over 3. Look at the tangent column. We go down to root 3 over 3. The angle associated with that is pi over 6. Okay, so now these next couple have negative signs with it. To do that, you're still going to use the table, but we're going to ignore the negative sign temporarily and then we'll apply it later. Let's suppose that this is just inverse cotangent of square root of 3. Now, this table does not have the inverse trig functions on it. You could expand it out if you want to, but actually this right here is sufficient to answer this one. Cotangent is the reciprocal of tangent. So, if I take the reciprocal of root 3, that's 1 over root 3, which is actually root 3 over 3. So, actually the angle I'm looking at here is going to be the same one I had before of pi over 6. But pi over 6 is not going to be the answer here because there's a negative sign there. We need to refer to reference angles. So reference angles, there's a pi over 6 over here. And then because you're looking for the place where cotangent is negative, that's going to be in this quadrant over here. Remember that the range for the inverse cotangent is between 0 and pi. So I'm going to have another angle over here that has the same reference angle, so it still has a value of pi over 6 over here, but I'll have a pi over 6 on this side. So what I want to do to find that one is I'm going to take pi minus pi over 6, because pi is the measurement of this line right here, and you're going to go back on a measure of pi over 6. So the answer for this problem is going to be 5 pi over 6. So the ones with negatives, they do require you to use reference angles. So this is your correct answer there, 5 pi over 6. Let's take a look at this one. Inverse cosecant negative root 2. So you want to look at the reciprocal of that, 1 over root 2. 1 over root 2, we saw earlier that if you rationalize it, it's square root of 2 over 2. So I'm going to look at the sine column, square root of 2 over 2. Now it gives me pi over 4 as the reference angle. But we want to look for the places where the sign is negative. And remember the range for inverse cosecant is between negative pi over 2 and pi over 2. So for this one, you have angle here which is pi over 4, and you have another angle down below there. So one going up and one going down. So pi over 4 is your reference angle going up, and then going down here is going to be pi over 4 negative. Because remember, because the negative sign, we have to consider the one that's down below here. To do that, you're going to take 2 pi, which is that measurement, minus pi over 4, and that's going to give you 7 pi over 4, and 7 pi over 4 would work. You could also put negative pi over 4 would be equivalent as well. But the answer usually when you do these online, they're going to tell you what range they want the answers to be given in, and so you have to look at what they want. Sometimes they say negative angles are okay, sometimes they'll say give us an angle between 0 and 2 pi, and that would be equivalently 7 pi over 4. So it just depends on what the question's asking you for. Let's look at this one, inverse secant of 2. Okay, so 2 we can write reciprocal as 1/2. Inverse secant refers to this cosine column. We're going to go down until we reach 1/2. That gives us a value of pi over 3. So again, why are we doing 1/2? Because secant is the reciprocal of cosine. So that's why we're going to look at the cosine column. 1/2 is reciprocal of 2. That means that this one's going to be pi over 3. Now, for this one here, inverse cosine is square root of 7 over 2. You want to first do that number, this number here, in a calculator. If you do, that's the same thing as inverse cosine of 1.32. Now 1.32, as I mentioned before, that's not a number that fits our domain. So you want to make sure that this number inside fits your domain. The only numbers we're allowed to put in inverse cosine are numbers between -1 and 1. since this falls outside, that means that we'd have to put undefined or does not exist for our answer, so this problem we can't do.